Okay, I'm going to explain a little bit about the determination of the molar mass of volatile liquids lab. This one's not too difficult as far as the calculations. I think you guys will be okay here. One of the harder things about this one, I think, is just understanding why exactly we are doing everything that we're doing in this lab. Okay, so the idea here is they're giving us sort of a central equation at the top here, the molar mass. This is the Mr. T poops violently equation right here. And that's the one that we're going to use in this lab to figure out the molar mass of these different liquids that we're going to use. And so you can kind of see here the different things that we need to know in order to calculate this molar mass. We need to know the mass of the liquid. We need to know the pressure and the volume of the liquid and the temperature. So as long as we know those things, then we can actually calculate the molar mass fairly easily. Now the difficulty is figuring out all those things experimentally. So that's what we're doing for the rest of this lab, is basically just trying to figure that out. So the pre-lab here says determination of the molar mass of methyl alcohol yielded the following data. And it gives you a temperature, it gives you a barometric pressure, it gives you the temperature of the room temperature water bath, and then the density of the water at room temperature. Okay, and so those are the sets of data that we probably need for this thing. And then it's giving you a chart here, and it's going to ask you to fill out the chart basically with the pre-lab questions. Let me see what the first one is here. Using the data. Oh, okay. So number one just says fill in the rest of the table. The volume of the pipette is equal to the volume of the water in the pipette, so you can assume that we filled this thing up to the top as much as it can possibly be filled with the water. So we took the mass of the empty pipette, the mass of the pipette and the condensed methyl alcohol, and the mass of the pipette and water. Okay, so we want to know the mass of the condensed methyl alcohol. So the first thing we have to do here is figure out what would be the mass of the pipette when it's completely empty. Actually, we already have that data. Okay, so here's the mass of the empty pipette, and then the mass of the pipette and the condensed methyl alcohol. So all we have to do here is subtract those two from one another, and that's going to give us the mass of the condensed methyl alcohol here. The mass of the water in the filled pipette. Okay, so the way that we can figure that out, we know the mass of the pipette plus the water, so we need to take the 16.001 minus the mass of the empty pipette, which is the 1.557. When you do that, whatever you find for the mass of the water, that's what's going to go in here, okay, for this number. And then we need to find the volume of the pipette. So actually, I guess I'll go ahead and calculate this so we can work it through. So I'm getting 14.444 for the mass of the water. So to find the volume of the water, if we've got 14.444 grams of water, then we can use the density of water at room temperature that they give us here, 0.9973, to calculate the milliliters of water. And that's going to give us the volume of the pipette, okay? Because we're going to assume that we filled this pipette completely up with water. So whatever the volume of the water is, that's going to be the volume of the pipette, okay? I guess this would be the 0.9973 down here, and this would be 1 up here. So whatever you get there, that's the volume. Molar mass of the methyl alcohol. Okay, so now we're going to have to use some of these numbers that we got here. So we just figured out the volume of the pipette. Okay, so that's our V. Okay, the mass of the condensed methyl alcohol, that's right here. Okay. So, in other words, when we have our molar mass equals MRT over PV equation, our mass is going to come from the mass of the condensed methyl alcohol. The volume is going to come from the volume of the pipette. The pressure is the barometric pressure, and I'll have to give you that in the lab again. And the temperature is... Now what we're going to use for the temperature here, we're going to use the temperature of the boiling water bath, okay, because that's, I believe that that's right. Let me double check that down in the lab. For the temperature of the boiling water bath, let's see here. Sorry, let me erase erase this so I can see. Yeah, I think the only thing that you need the room temperature for is to figure out the density of the water or temperature. Yeah, you're going to use the boiling water temperature. Okay, so, which is 99.5 degrees Celsius. So again, that's the, that's going to give you the molar mass, right? So, let me write this equation again, sorry. Distracted myself here a little bit. So you plug all that in. You've got, again, you've got your mass here. You know what your R is, okay? Your temperature is going to be the boiling water temperature. Change that to Kelvin. The pressure is going to be atmospheric pressure, barometric pressure. Change that to atmospheres if you're using the normal R, which you'd have to divide this by 760. And then you need to plug in the volume, and that would be the volume of the pipette right here. Whoops, I circled the wrong mass, sorry. You're not going to do the mass of the water, you're going to do the mass of the condensed methyl alcohol and the volume of the pipette. Okay? That's going to give you your molar mass experimental. Now, we know what the theoretical molar mass of CH3OH should be, okay? Because you can just look on the periodic table and you can figure that out. So once you figure out the experimental, you just use the periodic table for the theoretical, and that'll give you an idea of how close we are, and then they might ask you to calculate a percent yield or something like that. And then they have number 2 here. The following mistakes were made when carrying out the experiment. What effect does each have on the calculated molar mass? Okay, only part of the pipette was immersed in the boiling water, so the temperature in part of the pipette was less than that of the water bath. Okay, so again, you just got to kind of think about the equation here. Molar mass equals mRT over PV. Temperature's on top of that equation, okay? So if the temperature in part of the pipette was actually less than what we recorded, our recorded temperature is going to be too high, okay? And so if we're recording our temperature too high, then that's going to make the molar mass, the calculated molar mass, higher than it should be, okay? And then the mass of the condensed liquid was not determined quickly. Instead, the pipette was allowed to stand for a while before immersing it in room temperature water and then massing the pipette. So if that happens, most likely some of that vapor that's in the pipette is going to escape before you condense it, which is going to reduce the actual volume of the condensed liquid. Okay, so if that volume again, we're recording a volume that is too high for what it actually was, which is actually going to make our molar mass go down because that's on the bottom of the fraction. Okay, so that would decrease our calculated molar mass versus what it really should be. Okay, so those are the kinds of things you need to be thinking about on the pre-lab. Pretty straightforward stuff. What you're essentially doing on this lab is you are filling up, you've got these plastic tubes here, and you're filling them up with 3 different alcohols, and hopefully we can get to all 3 of those today, we'll see. But you're going to do 3 trials at once, essentially. That's why they've got all 3 of these going at the same time. And what you're going to do here is you're going to basically take some alcohol and put it in the bottom of each of these, and then you're going to heat them up until it all evaporates, okay? And so you need to heat it up until there's no liquid left, it's all gas. And so then, in this entire pipette, and all of these pipettes, you're just going to have gaseous alcohol filling it, okay? And then you're going to put it into a cold water bath very quickly to condense that, and so that, you know, the mass of the liquid that you have left in there, that's the vapor that actually was completely filling the container, okay? So that's going to give you your volume, because you know the volume of the pipette bulb, or you're going to figure it out eventually. Then we also have the mass of the of just the liquid, because we've already taken the mass of the pipette bulb when it's empty, okay? And then we're going to know the temperature of the boiling water bath because you're going to be taking that temperature, and then I will give you the barometric pressure in the room. So once you have those 4 variables, you can actually solve for the molar mass. And so you can figure out what the molar mass of each of these things should be. And then you can compare them to the known molar mass for that particular compound, and you can see how close you got. Okay? So make sure you record the temperature of the boiling water bath. I'll give you the barometric pressure, like I said. The temperature of the room temperature water bath, you're going to need that to figure out the density of the water at room temperature. And you probably just need to go online and find a table that tells you the density of water at certain temperatures, and that's pretty easy to find online. I've never had trouble with that in the past. Then you're just going to record all this stuff for each of your different things. And again, trial 1, trial 2, and trial 3. You're doing all of them at the same time because you're doing 3 pipette bulbs at the same time. Okay. Post-lab calculations determine the mass of the condensed volatile vapor for each pipette trial and each liquid. Okay, that you're going to do just based on your other data that you have recorded. Okay, and actually, if you look back up here, so you've got, in your original data table here, you're going to record the mass of the empty pipette. Okay? And so then if you, for each of your volatile liquids, if you take the mass of the pipette plus the condensed isopropyl alcohol, for example, or the mass of the pipette and the condensed ethyl alcohol, just subtract the mass of the empty pipette from that, and that'll give you the mass there. Okay? And then you should be able to use that calculation we talked about on the pre-lab to figure out the molar mass of each of these things and see how close you got. Use the CRC Handbook of Chemistry and Physics to determine the density of water at the temperature. Now, they say to use the Handbook of Chemistry and Physics. Again, you should be able to find this online. It shouldn't be that difficult. Determine the mass of the condensed volatile liquid for each run. Okay. Again, I just told you how to do that. Calculate the molar mass of the liquid used in each run, the average. And again, you're using Mr. T poops violently for number 4 here. Okay, that's the one that you're going to use there. Volatile liquids with lower boiling points often give better results than those with higher boiling points. Suggest a reason for this. I'm going to let you think about that one. I think you can figure that out. What effect would vapor condensation in the neck of the 15 milliliter bottle? Okay, and then again, these are just... these last few questions here are basically just, sorry, let me get back to that, questions that ask about the errors that could be caused in the experiment, okay? And we talked about a couple of those on the pre-lab, so hopefully you're thinking enough along those lines. Again, just use the equation, write out the equation, molar mass equals mass times R times T divided by P times V, and think about each of these scenarios on 5 through 7. What would they change, okay? And then think about how would that affect the molar mass. Okay, actually, that's actually 6 and 7 too that you're going to do that for. And so I think you guys can actually figure out the errors on those too. So that's about it for this lab. There's not a lot to it. Hopefully that makes sense. I guess just make sure and have this done as soon as possible. It'll be due Wednesday when you get back from Thanksgiving break, the day after the test. So, all right. Have a good break.